going to the second session of our second video. So in this video, the first video, I have already explained about the functions, domain, range, and its example. How can you find out this functions, domain, and range with the example. Next, I think you have already studied about it and you understood about it. And so I am going to the next portion. So interior and interior points and boundary points of the unit points. So what do you mean by an interior point? Point in two dimension. So what is an interior point? Is an interior point. A point x0, y0 in a region R in xy plane is an interior point of R if it is the center of disk, if it is the center of a disk that lies entirely in R, that lies entirely in R. So that is, suppose this is a region R. Suppose a point x0, y0 is an interior point, means you can find out a disk such that disk completely lies in that region. And we say that this point is x0, y0. If the disk lies in between in this region, inside this region, we say that this is an interior point. Otherwise, this will not be an interior point. So, interior point next boundary point. Also, there is an exterior point. Exterior point means a point is an exterior point if it is the region. This region completely lies outside. Then this point is known as exterior point. Point here, a point is this is an exterior point, so because you can find out a disk such that this is completely lies outside. So you cannot every point lies outside. This is exterior point, and this is interior point, and next we go to boundary point. Boundary, this is the boundary. So when you draw a disk centered with this point, then in this points, some points lies in the region and some points lies outside the region and some points lies inside the region. Then this point is known as, this is known as the boundary points. Okay, so this is the interior point and this is boundary point. So if you draw any disk corresponding to this point centered with at this point, then some points lies inside the region and some points lies outside the region. So this point is a boundary point. Okay. So next is a region. When a region is said to be bounded. When a region is said to be bounded. A region is said to be bounded if it lies inside a disk of fixed radius. If it lies inside a disk of fixed radius. So unbounded means if it is not bounded. If it is not bounded, it is called unbounded. Right? So this is a line segment, right? You can find out a disk corresponding to this such that you can a fixed radius such that this line segment is inside this disk. So we say that this line, so this is a bound example for a bounded set. Again a triangle. I can draw a disk such that this triangle is inside this disk. Then this is said to be bounded. So again the interior of triangles, rectangles, disk. These are examples of bounded sets. Unbounded sets are lines. Lines you know that unbounded sets. Unbounded sets example is lines, coordinate axis, the planes, half planes, etc. These are the definition for bounded sets. Okay. So next one we are going to define open set, closed set, neither open nor closed. Open set, a region B is said to be open if it consists of entirely of interior points. Consists of entirely of interior points. So a region is said to be closed if it contains its entire boundary also. Right? If boundary is not there, then we say that it is open set. If boundary is included, then it is said to be a closed set. Okay. So example for this open set. Example for open set. Open balls. Will be another example. Open half space. First obtained. Space, etc. These are the example for open set. So what will be the example of closed set? You know that, right? Lines, planes, closed balls, closed half space, space, etc. A space which is not closed, not open means which is neither closed nor open. Right? So look at example. Example f of xy equal to root of y minus x squared. What was the domain? Domain is equal to set of all xy such that y greater than or equal to x squared. That means this is y equal to x squared. So y greater than means this, right? So this is y greater than and y equal to x square is this one. Y greater than x square is the point lies here, right? So this is a boundary point plus interior point. So the domain is said to be closed. And you cannot, uh, this is going to infinity. This is actually to infinity. So you cannot put this figure into a disk. So you cannot say that this is bounded. So you cannot put this figure into a closed disk with a fixed radius. So you cannot say that this is bounded. So this is unbounded. This is unbounded. Okay, thank you.